Because the last period it didn't. And there we go. Now we're recording. So our thought for the day is the future you see defines the person you will be. What does that mean? The future you see defines the person you will be. Anyone?
Like, does it mean if you go after a certain future, it'll define the person that you'll become in that future?
Okay. Anyone else? Yes. Anyone else? If you set a goal towards something, you're going to work towards that something, right? Remember, we talked about successful people. Successful people are people who have successful habits. And one of the successful habits that we have is we have to have some goals. We have to set some goals. If we don't set a goal to work towards something, then we're not going to get there, right? So what we have to do is we have to make sure that we're setting goals that help us get to where we want to be. And if we set those goals, we're much more likely to get to that future that we see. Okay? So goal setting is important. It's one of the things that successful people do. And whatever you define as success is great. There's nothing wrong with that. But you also need to set the goals that are going to help you get to where you want to be. And if you don't, if your goal is to go to college and you don't set the goals to get the grades to go to college, or set the goals to get the money to go to college, or set all those kinds of things, then you're not going to get there. And that's just one little small goal. Those are things that you've got out there for the future, okay? But if you don't set some goals, you won't get there either, all right? So, any questions about last night's homework over section 1-2? Now, on last night's homework, there were 2 free response questions. One of them required having a $sign, okay? And I didn't put that in there, and I should have. But if you got it wrong, that's okay. Remember, homework doesn't the only homework assignments that I'm collecting are the ones that are on the syllabus. If you look on my syllabus, if it's in green, that's a homework assignment that I'm going to collect. If it's in red, it's a quiz that we're going to take or a test that we're going to take, okay? So it's kind of color-coded. And then the pink would be the extra credit that's coming up on October 7th. So you remember, you can go ahead and start on that extra credit. The homeworks, like the daily homework, if it doesn't say it's being collected for a grade, it's for your purposes, making sure that you know how to do the problems, okay? So I'm not taking a grade on those kinds of things. It says on the syllabus exactly what we're going to get grades on. One of the things that's coming up next week is, remember on Friday you took your test, and one of the things was to do the modern states. You guys who are here in class, whether you're in class hybrid A or hybrid B, all the hybrid A, hybrid B folks are going to show that to me when you're in class. So for you guys, you'll show it to me next Wednesday. For those of you who are at home who are hybrid A, you'll show it to me next Tuesday. You'll actually pull up your modern states account. You'll go to the progress part, which is a bar chart. You'll show me that bar chart, and I'll record your grade while you're here in class, okay? If you are virtual, then you will take a picture of that progress, and you will email that to me, and I will give you your grade on that, okay? It's on your syllabus. It was Modern States, the College Algebra, module 1.1 and 1.4. Not 1.1 through 1.4, 1.1 and 1.4. So I think it was a total of about 6 questions, okay? But it's 1.1 through 1.4. And it's always going to be on your syllabus, the syllabus that's on Schoology. And it tells you when it's due also, okay? Sir? Well, for purposes of a grade in here, it's for attempt and completion. But remember, in order to get your voucher for modern states, that part's for accuracy. Okay, so I'm only going to be looking to see that you did what you were supposed to do. Okay, remember, every single time we take a test, that's when you're going to be doing the modern states, and it'll be the modern states modules that are completely covered in anything that we have done before. So if there are 4 modern states questions and 3 of them come from chapter 3 and 1 of them comes from chapter 4, I assign it at the end of chapter 4. Okay? because if I assigned it at the end of chapter 3, there'd be one question you wouldn't be able to do, one that I hadn't shown you yet, okay? So it's when the last modern states question that's in that module is completed, that's the chapter I'm going to assign it in, okay? All right, any other questions from last night's homework? All right, then today we're going to be looking at complex numbers, imaginary numbers and complex numbers. And we're going to be adding and subtracting complex numbers. We're going to be multiplying complex numbers. We're going to be dividing complex numbers. And we're going to be performing operations with negative numbers under the radical. So it should be a review from Algebra 2. But let me remind you about imaginary numbers. René Descartes, the same guy who came up with the Cartesian plane, the coordinate plane that we do, he decided or said that in mathematics, so many times we come up with a square root of a negative number. We have to be able to a way to deal with that. And so he defined that the square root of negative 1 is I. That's the imaginary number I. Then what follows out of that is that I squared would equal negative 1. I cubed would equal negative I to the 4th power would equal positive 1. And then, of course, we also know that I to the 0 power, anything to the 0 power is positive 1. So if you know those 5 things, you know a lot of information about complex numbers, okay? So the square root of negative 1 is the imaginary number I. I squared equals negative 1. I cubed equals negative I to the 4th power equals positive 1. And I to the 0 power equals positive 1, because anything to the 0 power equals positive 1 by definition. And then from the imaginary numbers, we have a new number system called the complex numbers. And remember, with complex numbers, we have to have it has to be an a plus bi form, where a is the real number part. Those are those numbers we talked about in chapter P. And then bi is the imaginary number part. So if I had something like 6 plus 2i, that's a complex number in good complex number form, a plus bi, where 6 is the real number. How do I know 6 is real and not imaginary? Doesn't have the I with it, right? The 2i, the I means it's an imaginary number, okay? So I could have 5 minus 3i. That's a complex number. The real number part is 5, and the imaginary number part is negative 3i, okay? If I just had 4i, would it be okay to put 0 plus 4i? We could write it like that. If they tell us to put it in good complex number form, we would want to write it like that, okay? And if we just had 12, could we put it as 12 plus 0i if they told us that we had to write our answer in a plus bi form? Because 0 times I is 0, and I can add 0 to anything and not change its equality. Y'all with me? So we're going to be dealing with imaginary and complex numbers in this section, which is a review from Algebra 2. And so here they want us to add these two complex numbers. How do I know they're complex numbers? Well, remember, we have a real number part and an imaginary number part. And a real number part and an imaginary number part, and we're adding them. So what does that complex number, this complex number right here, this negative 2 plus 6i, what does it kind of look like? Does it kind of look like a binomial? It's not a binomial, but guess what? We treat it like a binomial. We do the same things to it. So if we were going to add two binomials, how do we add two binomials? We add the like terms. Well, guess what? With complex numbers, that's exactly what we do. We add the like terms. So in this case, the like terms are the real number parts, okay, negative 2 plus 4, which gets us positive 2, and the imaginary number parts, 6i plus negative 1i would be 5i. We want to write our answer in good form, a plus bi form, but that is a plus bi form. We want the real number first and the imaginary number second. And so our answer would be 2 plus 5i. Easy, remember seeing that? Okay. Same kind of thing here. We're adding or subtracting complex numbers. Okay, we hate subtraction because we might mess up with our signs. So what can we do to take care of the subtraction part and not mess up our signs? Distribute the negative or add the opposite. Same thing here, add the opposite. And now we're just back to adding these numbers. Okay, so if I add those, I'm going to add the real number parts, the 7, the 9, and the 17. 7 plus 9 is 16, plus 17 is 33. And then the imaginary number parts, the negative 2i plus positive 1i, which would give us negative I. So my answer in good form, in a plus bi form, would be 33 minus I. Does this seem really, really easy? Well, the reason that we do that is because it's on the CLEP test, okay? You're probably going to find every single time that I go through this, I'm going to say, the reason we're doing it, it's on the CLEP test. And here's some examples of it, okay? So in this one, they ask us to add these two together. I'm going to write it over here so I can add them together. So that's 3 plus 4i plus 2 minus 5i. Remember, they told me to add right there. So I just add the real number parts. 3 plus 2 is 5. 4i plus negative 5i is negative I. So I'm looking for 5 minus I. Super easy. Same thing here, only we're subtracting, okay? We're subtracting, so we're just going to write them out and subtract. Everyone with me? And remember, can you get to those problems on your Schoology page? Yeah, they're on your Schoology page. You can go back to them. All right, so what are we doing here? We're taking an imaginary number times kind of a complex number. It's not in good form, but it is a complex number. It's got a real number part and an imaginary number part. How do we multiply those? Good, we're just distributing, right? So that imaginary number is kind of like a monomial, and that complex number is kind of like a binomial. And to do that, we're going to distribute. So we're going to distribute here and here, which means that we're going to have negative 8 times 2 is negative 16, and I times I is I squared. And then negative 8 times negative 7 is positive 56i. Is everyone with me so far? But remember, we always want to put our answer in simplest form. Can we simplify anything there? The I squared, because I squared equals what? So I could substitute that in, and I could say that that's negative 16 times negative 1 plus 56i, or that's 16 plus 56i. So in final form, in good A plus BI form, it's 16 plus 56i. Y'all with me? Is that not bad? Well, here what do we got? We've got two complex numbers. But remember, we said complex numbers kind of look like binomials, and we treat them like binomials. So how do you think we're going to multiply these two complex numbers together? Foil it, right? So we're going to FOIL. We're going to multiply this and get negative 24. We'll multiply this and get positive 72i. We're going to multiply this and get positive 12i. We're going to multiply this and get negative 36i squared. Is everyone with me so far? Can we simplify anything? The I squared. So I squared we know is negative 1. So that's negative 36 times negative 1, or positive 36. So now we can add those together, and we'll have negative 24 plus positive 36 is 12, and 72i and 12i is 84i. So in simplest form, we think, or in good complex number form, we think that our answer is 12 plus 84i. Super easy? Not bad?